Alright, the next topic is about adjoint and inverse of a matrix. Okay, so let us first of all try to know what is adjoint. Your adjoint of a matrix. So suppose let a matrix A is equal, now remember we're doing a matrix, so always give a matrix sign. Your A11, A12, A13, A21, A22, A23, A31, A32, and then A33. Suppose this be a matrix, and this matrix is of order 3 into 3, that means 3 rows and 3 columns. Then the cofactor of A would be nothing more than your cofactor of A would be nothing more than A11, A12, A13, A21, A22, A23, A31, A32, A33. Now if you can see there's difference. Here I've got small letter A and here I've got capital letter A, okay? Your capital letter A denotes your cofactor. And if you're thinking what is cofactor and if you don't know, please see a previous video. Alright, then comes the adjoint. Then the adjoint of matrix A is nothing more than the transpose of the cofactor of A. That is, your adjoint A would be the transpose of this matrix. That's a cofactor. So it will be of transpose of the cofactor. The transpose means on exercise 3, or we have studied transpose. A transpose, it means nothing more than the row will change into your column. So that will be your A11, A12, A13, A21, A22, A23, A31, A32, A33. So that is, in short, your adjoint of A is nothing more than A11, A12, A13, A21, A22, A23, A31, A32, A33. That's your explanation of your adjoint. The definition, it's popping up there. You can just see the adjoint of a matrix. If you're not clear with the definitions, your textbook, once you'll be much more clear. Then before I go forward, there's actually two definitions. The first definition is about a singular and next definition is about the non-singular. Alright, the singular is given that a square matrix A is said to be singular if determinant of A is equal to 0. Similarly, a square matrix A is said to be non-singular if determinant of A is not equal to 0. I hope you're clear till there. Alright, now one more thing. In a previous exercise, we have done cofactor. And if you can look over there in cofactor, their formula for cofactor is nothing more than Aij is equal to minus 1 I plus j Mij. Your M is nothing more than minor. Now, keep a focus on this line, minus 1 I plus j. Okay, so I'll just try to teach you in a very easy way. Always to know that whenever I plus j happens to be even, then your cofactor would always come out to be positive all the time. Similarly, if I plus j, the answer came out to be odd, then your cofactor would always be negative. Okay, let me try to do with example. What do you mean by it? Suppose I say A is equal to 1, 2, 3, 4, and I say A11. Now look here, 1, 1. That means 1 plus 1 is how much? 2. 2 is even, so answer will be positive. So 1, 1. First row, first column gone. The answer is 4. Similarly, A12. Here 1, 2. It means 1 plus 2 is odd. Odd means negative, so it will be first row, second column gone. The answer is minus 3. And your A21, second row, first column. 2 plus 1 is 3. 3 is minus, so second row, first column. So answer is 2. And your A22, 2 plus 2 is 4. 4 is even. The answer will be positive, so 2 2, answer is 1. So here your adjoint of A would be nothing more than, that's your A11, A12, A21, A22, so which is 4 minus 3 minus 2 1. So that's your answer, and this is all about your adjoint. So the next topic is your inverse of a matrix. Your inverse of matrix, you can see the definition in your textbook. I'll just try to teach you how to use the inverse of matrix. Okay, like what's the formula? So formula for finding inverse, that is your A inverse. So it will be, let A be a square matrix such that your determinant of A is not equal to 0. This is a very important point. Okay? Your determinant of A should not be equal to 0. That should be a non-singular determinant. Clear till there? Then your A inverse is nothing more than 1 by determinant of A and then your adjoint of A. That's all about your finding the inverse of a matrix. Now how to do the inverse of matrix we'll do once I start the exercise. Okay. Alright, let us do exercise 4.5. It's given that find the adjoint. The first question is given to be this one, 1 2 3 4. I've already given let A is equal to 1 2 3 4. Now before we find the adjoint, you should know the cofactor. And if you know that I've already teach you your if I plus j happens to be even, then your cofactor would be positive, and if I plus j happens to be odd, then the cofactor would be negative. So here I got A 1 1, so 1 plus 1 is 2. 2 happens to be even, so answer will be positive. So first row, first column gone, the answer will be 4. Similarly A 1 2, 1 2 means first row, second column gone. 1 plus 2 is 3, so minus 3. Why minus? Because 1 plus 2 is 3. 3 happens to be odd. Similarly A 2 1, 2 1 minus, so 2 1 will be 2, and A 2 2, 2 2, so that will be 1. So therefore your adjoint of A is nothing more than A11, A12, A21, A22, so which happens to be 4 minus 3 minus 2 1. So that's your answer. Alright, let us do question number 2 in a similar way. Your question number 2 is of matrix 3 into 3, so it's given 1 minus 1 2 2 3 5 minus 2 0 1. So same thing, I'll just do let A is equal to the same matrix 1 2 minus 2 minus 1 3 0 2 5 1. So let him start with A11. Your A11, 1 plus 1 is 2, so it's positive. Okay, so 1 1, so that will be 3 5 0 1, so that will be 3 minus 0 3. A1 2, 1 plus 2 is odd, odd is negative, so minus, so 1 2 is first row, second column gone. So first row, second column gone, so the answer will be how much? 2 5 minus 2 1, so that will be minus 2 minus 10, so which will be minus 12. So that was all about your A12. Let me do A13. 1 3 means first row, third column gone. 1 plus 3 is 4, is positive. Okay, first row, third column, so that will be 2 3 minus 2 0, so that will be 0 minus 1 minus 6, happens to be 6. Similarly your A21, it's minus, so your A21 you will get the answer to be 1, so that's minus 1. Your A22, you solve it, your A22 would be second row, second column gone, so if you solve, you will get the answer to be 5. And your A23, second row, third column, second row, third column, if you solve, you will get the answer, because A23 is odd, so minus, so that will be 1 again, so which is minus 1. Similarly your A31, it's 3 plus 1 is 4, 4 is even, right? So 3 1, if you solve, minus 5 minus 6, the answer will be minus 11. A32, your 32 is minus, so 3 2, So 1 5s are 5, 2 2s are 4. 5 minus 4 is 1. So that's 1. So the answer will be minus 1 and a 3 3. 3 3. So 1 2 1s are 3 minus 2 plus, so 3 plus 5, 2 is 5. So the answer is 5. So therefore your adjoint of A would be nothing more than your A11, you got it to be 3 minus 12, 6 minus 1, 5 minus 1 minus 11 minus 1, 5. So that's all about your adjoint of a matrix. Alright, let me jump. It's given that find the inverse of each of the matrix. Equation number 5 is given to be 2 minus 2 4 3. Okay, before we find the inverse, if we can just see over here, in order to find inverse, we just have to see that it's a non-singular matrix. So in order to find non-singular, I have to find the determinant of A first. So your determinant of A would be nothing more than 6 minus 2 4s minus 8. So that is 6 plus 8, which is 14. So in short, your A inverse exists. So then I have to, next of all, I have to find the adjoint of A. In order to find the adjoint of A, I have to find the cofactor first. So your A11 would be 3. Your A12, 1 2 means odd, so minus. So first row, second column gone. So 4. Your A21 minus. So 2 1. So it will be minus 2, which is 2, and your A22, which is again 3. So therefore your A inverse, according to the definition, it's nothing more than this one, your adjoint of A. So 1 by, I got this one to be 14, then it will be 3 minus 4, 2 3. So that's all about your question number 5. Okay, let me just do question number 7 next. Your question number 7 is given to be this one. Let A is equal to 1 2 3 0 2 4 0 0 5. Now this is of matrix 3 into 3, okay? That's of order 3. So let me first of all find and see whether the determinant of A will be equal or non-equal to 0. So if I do that, I will be 1. I'm going to do this first row is plus minus plus 1. So 1 is this and this gone, so that will be 2 4 0 5 minus 2. Minus 2 means this and this gone, so it will be 0 4 0 5 plus 3. 3 means this and this gone, so that will be 0 2 0 0. So I got the answer to be 1 10 minus 0 minus 2 0 minus 0 plus 3 0 minus 0. So that should be 10, which is not equal to 0. So therefore your A inverse exists. Now similarly your A11. Your A11 means first row, first column gone. Then I got the answer 10. Your A12, 1 2 means minus, because 1 plus 2 is odd. Okay, odd is always negative. You to remember that. Alright. So so minus. So A12, I got the answer to be 0, so which is 0. Similarly your A13. 1 3 is plus, so 1 3, and the answer is 0. And your A21. 2 1. Actually 2 plus 1 is 3, so minus, okay? 2 1. So if you solve it, 2 5s are 10. So answer 10. A22. 2 2. So if you solve it, you'll get the answer to be 5A23 minus. So 2 3. The answer is 0. The answer is 0. A31. 3 1 is positive, so 3 1. 2 4 is 8. 6. So 2 A 3 2. 3 2 is minus. So 3 2. 4 1 is 4. So it's minus 4, and then A 3 3. 3 3. The answer is 2. So therefore your A inverse would be 1 by 10, and then you'll get the answer to be 10 0 0 minus 10 5 0 2 minus 4 2. So that's your answer. Alright, let us do question number 13. The question number 13 is given to be, if A is equal to 3 1 minus 1 2, show that A square minus 5A plus 7I is equal to 0, hence find A inverse. Okay, before I found this one to be 0. Let me just try to find what is a square. Your a square happens to be a into a. So a I got 3, 1 minus 1, 2. Similarly, 3, 1 minus 1, 2. Now, nothing is between the two matrices. That means I have to deal it with multiplication. So the multiplication of two matrices, you know the formula, it's row into column. So the first row with the first column, I'll get the answer, nothing more than 9 minus 1. Similarly, the first row with the second column, 3 1s are 3, 1 2s are 2. Now the first row is done with all the column. Let us go with the second row. The second row is minus 3 minus 2. Similarly, the second row with the second column, so there will be minus 1 plus 4. I got the answer to be nothing more than 8, 5 minus 5, 3. Now let me take on the left hand side of this one. So if I haven't taken left hand side, I will be getting a square minus 5a plus 7i. Your a square, I got it to be 8 minus 5, 5, 3 minus 5. Your a, it's nothing more than 3, 1 minus 1, 2 plus 7. Now here your I is nothing more than your identity matrix. Now we are dealing with two rows and two columns, so it will be 1, 0, 0, 1. Now let me put everything under one matrix. If I put everything under one matrix, I'll get the answer 8 minus 15 plus 7, 5 minus 5 plus 0, minus 5, minus and minus plus 5 plus 0, 3 minus 5 2s are 10 plus 7. So if you can see, I got everything to be 0, 0, 0, 0, nothing more than 0, so which is equal to your right hand side. Alright, the first part of your question is done, which is I have to prove this one to be equal to 0. Now let me try to find here A inverse. Now let me try to find the A inverse in a little bit different way. So as we know that your a square minus 5a plus 7i, I got it to be 0. The next thing I'm going to do is multiply. I'll just do this one. I'll do 7i is equal to 5a minus a square. What I did, I put these two over here. I hope you're clear until there. The next thing I will do here is multiplying a inverse on both sides. So if I multiply a inverse on both sides, I'll get here 7i a inverse equal to 5a minus a square a inverse. I guess again you are clear till there. So it will be 7i a inverse is equal to 5a a inverse minus a inverse. A squared, I can write down a into a. So I into anything is the same thing, so that will be a inverse 5. A into a inverse nothing more than your I minus similarly a into a inverse nothing more than your a into I. So I got the answer 7a inverse is equal to 5i minus a, which is nothing more than 5. Your I is 1, 0, 0, 1, and your a happens to be 3, 1 minus 1, 2. So I got 7a inverse is equal to, so that will be nothing more than 5 minus 3, 5 into 0, 0, so 0 minus 1, 0 plus 1, 5 minus 2, so which is nothing more than 2 minus 1, 1, 3. So therefore your A inverse is nothing more than 1 by 7, 2 minus 1, 1, 3. Okay, the next question happens to be this one. Question number 14 is given that for the matrix A is equal to 3, 2, 1, 1, find the numbers A and B such that A square plus AA plus BI is equal to 0. So I have to find the value for A and B. So given that A square plus AA plus BI is equal to 0. Your A square, it means nothing more than A into A plus A. Your A happens to be 3, 2, 1, 1 plus B. Your I means your identity matrix, that is 1, 0, 0, 1 equal to 0. Now your A into A, it means 3, 2, 1, 1 into again 3, 2, 1, 1 plus, let me put A inside the matrix. I'll get here 3A, 2A, A plus similarly I'll just put B inside the matrix. So B 0 0 B 0. Now let me solve this one. If I happen to solve this one, I'll get the answer nothing more than 3 3 is a 9 plus 2. Similarly, row with the second column, so 3 2 is a 6 plus 2. Down with the first row, now second row 1, so it will be 3 plus 1, and similarly 2 plus 1 plus it will be 3a 2a a plus b 0 0 b is equal to 0. So I'll get the answer over here, nothing more than 9 plus 2 is 11, 8 4 3 plus 3a 2a a plus similarly b 0 0 b. Now on the right hand side I got the equation to be 0. 0 means I can write on the matrix to be nothing more than 0 0 0 0. That's your 0 matrix. Now the left hand side, everything I'll put it under one matrix, so I'll get the answer 11 plus 3a plus b, 8 plus 2a plus 0, 4 plus a plus 0, 3 plus a plus b is equal to, again same thing, 0 0 0 0. Now between these two matrices, between them I got equal to, that means this matrix is equal to that matrix. You can take the same elements of both these sides. So try to take the easiest one. Let me go with the third element of the left hand side, similarly third element of your right hand side. So I got here, so here 4 plus a is equal to 0, so a happens to be minus 4, and similarly I'll take the fourth element, so it will be 3 plus a plus b is equal to 0, so b is equal to minus 3 minus a, so that is minus 3 minus of minus 4, the answer is 1. So hence I got the value for a to be minus 4 and b to be 1.